Peter Reynolds. I'm an analyst with ARC Advisory Group, and today we're going to be talking with Dave Hokanson, Process Control Specialist with ExxonMobil, about process optimization. Hi, David.
Hello, Peter. Glad to be here.
Tell me about ExxonMobil, what you do, and a little bit about your company mission.
Well, most people know what ExxonMobil is. It's a very large integrated oil and gas company, integrated in the sense that we also have refining operations and we have chemicals. And I work in the chemical side, and the chemicals is actually one of the largest chemical companies in the world, as well as being a large refining, associated with the refining and oil and gas production company. So that's what Exxon does. My job is actually a specialist in advanced process control. I go around to sites within ExxonMobil Chemical and implement applications of the model predictive control technology to improve their operations. Many times, most times these days, saving energy in the process.
So energy management seems to be a hot topic these days, with many factors that require industries to focus operations on energy. Can you talk a little bit about how advanced process control systems are being used in utility systems to support energy management?
Yeah, I'd be glad to. Energy is very, very expensive, and a key part of our focus, which is we have 4 key things right now we're looking at, is safety, security, health, and environment. And environment and energy are tied very closely. We want to reduce the amount of emissions, which involves production of energy. And so a key focus of our company right now is energy reduction. We've looked recently at utility systems, and we've given a lot of opportunities to reduce energy costs and energy consumption in the utilities area by applying something that was typically not used for utilities control before, which was model predictive control, such as DMC Plus from AspenTech, which is a product that we actually usually use. And so we've looked at that, and we looked at an example of talk I gave today. We talked about 2 areas. One was a fuel gas system, where we had lots of oscillations and disturbances that were resulting in a consumption of more energy than we'd like to have, and actually a fair amount of extra energy that we didn't need to be using. We used model predictive controls to reduce that excess energy. In the steam system, we were able to use model predictive control to actually reduce the amount of energy we used by maximizing the use of the efficient boilers, in this case turbine generators that are also producing electricity, which is an efficient way of making steam, and reducing the on-purpose demand unless we really needed it against the number of system constraints. It's a perfect application for a tool such as DMC Plus.
So DMC Plus has been around for a few decades. What factors are causing companies like ExxonMobil to consider using DMC Plus for utility applications?
Well, it's interesting. It has been around for 20, 25 years, but it used to be a very manpower-intensive effort to implement. So you needed a lot of credits, and typically they were throughput-driven. Recent innovations coming along the lines of automated step testing tools have resulted in a reduction in the amount of effort it takes. So you can do an application in a very short period of time, in a matter of a few weeks' time instead of many months. That payback becomes such that you can actually use it to look at other opportunities, such as utility controls. That plus the speed of computers has become the point where we can actually run the DMC applications a lot faster at a higher frequency, because steam systems and utility systems are generally have a short dynamics and they move around a lot faster than a typical chemical process. And so we can actually use that to run faster, and so computers are there, let's go ahead and use it. There's another development, which is also the modeling development. The model identification tools that have come out of academia that have been finally commercialized have led to the fact that we can actually use with less plant data. And unfortunately, model predictive controls, meaning you have to test the plant and analyze the data. And we used to have to have a volume of test data, and we now can reduce it down to a very small amount because of these improved model predictive control, the identification techniques, such as subspaces being one of them. So between the automated testing tools and the subspace identification, we've actually shrunk the effort down to a very, very short period of time. So again, that's allowed us to look at things like utilities, processes that we never thought that this technology would be applied for. Most of it actually recently in the last few years has been energy reduction. That's been our main focus with the use of this tool.
So where else is DMC Plus being used across the Exxon organization? Can you talk a little bit about other applications?
Well, it's very much still used heavily in our olefins, which is a large chemical operation producing ethylene, which eventually goes into plastics, and aromatics. and also used a lot in our refining processes, but we've also gone now recently into specialty operations. So we have specialty chemical operations, we've had polymer operations, and we're finding that because we can do things very efficiently and very fast, that the payback time, even though the credits may not be as big, we can still get a lot of benefit out of it. And again, a lot of it's driven by the energy reduction that we can get.
Okay, in terms of, you talked a little bit about the process modeling advances. Right. Can you talk a little bit about recent advances that you folks are making?
Well, one of the things we're doing is, I mentioned subspace as being one of the things, modeling identification, the tools that have come out of academia in the last few 20 or 30 years. The other thing we're doing is we're actually using real economics, and we're getting the real economics from steady state models that are applied to our process. We have things called energy real-time optimization applications, which they have a steady state model, not a dynamic model like model predictive controls use, but a steady state model of the process that's updated every 30 minutes or every 60 minutes, coming out with recommendations. That information in that model can give us efficiencies on boilers, which we can then use directly in our DMC Plus applications to come up with real costs, and then we can drive our process in the most economic way, and again, reduce our energy consumption because we use the most efficient boilers, for example. The site I just was at, we had 5 boilers. Each one had slightly different efficiencies, but the variety was huge. So the point where actually coming from this energy RTO application, we can actually come out and actually set the cost for steam for each of those boilers. And that way the DMC can then be driving that process to the most economic as well as energy efficient way.
David, that's been great insight. Thanks very much for talking to us.
Oh, I enjoy it. I have a lot of passion for the technology and applying this stuff, particularly to reduce energy consumption.
We've been talking with David Hokanson, the Process Control Specialist with ExxonMobil. Thanks for watching.